Hello everyone, now we are going to present our sediment transport analysis and management in river system of Sungai Congkak. Introduction. Based on our mini project, we're going to learn the sediment transport. Sediment transport plays a crucial role in shaping Earth landscape and influencing the various environmental effects and processes. Sediment transport is the movement of solid particles typically due to a combination of gravity acting on the sediment and the movement of the fluid in which the sediment is entrained. On this mini project is focused on sediment transport analysis and management which are having demand in engineering level. We choose Sungai Congkak to study the sediment transport analysis and management. The reason why we select this site is because in radius 10 kilometers there is an existing hydraulic structure which is Langat Dam, and the second is the recreation, and the third one is the resident. So we want to know whether these three may be affect the sediment transportation analysis. Data and observation. On this section, we are going to know the required data that needed. Second is the equation that we use, and the third is the observation based on the equation that we get. The first step is by collecting the data of the river, which is length, depth, and width. Three of these data must be collected with the unit of meters. This is to show how the cross-section will be taken to measure the river. Since the river that we took is 100 meters, so we must split it into 5 sections. This section is splitting by 20 meters to 20 meters as we shown in the figure. So all of the three data will take as the average of the measurement, as we want to know the ideal of the exact measurement on each, which is the length, width, and the depth. The reason we splitting into 5 sections is because every of the cross section of the river is different, so it is better to take more than 3 different measurements to know the ideal measurement. Time taken data of the flow. The tools that we use to taken the data is the timer, and also the ping pong balls. So the ping pong balls that we use is 5 ping pongs. The time taken of the flow must take as we want to know the velocity of each flow of the river. By releasing all of the 5 ping pongs, we observe that there is a different time and also different path flow along the river. So by this information that we took all of this time, we'll get to the average time as we want to know what is the ideal time of the flow of the river. So based on this image, we know that from the starting point until the midpoint shows the ping pong flows in the 2 paths, which is the 2 star that we shown in this image. However, even though it gives a 2 different path in the mid, it still ended in only the same path at the end point. It's not go into the left side, and it only goes to the right side as shown in the image. This is the average data that we have taken from all the measurement, from length, width, depth, and time. The purpose of this data taken is we want to know, or we want to calculate into the flow rate equation. As shown in the equation, flow rate equals to the volume divided by time. So the volume is based on the cross-section of the river, as we get the length, width, and the depth is all multiplied. Then after we multiply, we divide it by the time taken, the average time taken that we take, which is 88.x seconds. So based on these 4 data and we insert into the equation, we get that the flow rate of the river is 9.01 meter cube per second. Based on the flow rate result that we get before, now we can do the observation of the river. As we know, flow rate may impact the motion of river and also the sediment transport. In this study case, we are going to focus on the sediment transport. In this section, we are going to know the impact of flow rate to sediment transport is that as sand and silt are light, so they can be transported even by the slow rivers, while for gravel and boulders are heavier and these need much faster current to start moving them. The primary process of this sediment transport is traction, siltation, suspension and solution. Now we got to observe the sediment load of the river. As we know, sediment load has three types, which is suspended load, bed load and dissolved load. At the side, we observe there is two types that we can see, which is the bed load and suspended load. Bed load consists of the larger and heavier particles that move along the river or stream bed, while for the suspended load, it comprises smaller and lighter particles that are carried within the water column. The next one is the observation of the existing hydraulic structure that we can find. So, existing hydraulic structures can significantly influence the sediment transport in rivers and other water bodies. The interaction between water flow and sediment transport is complex, and hydraulic structures can alter the natural sediment transport processes in various ways. The first one that we observe is the Langat Dam. Langat Dam is within 7 km length away from the site of Sungai Congkak that we choose. We can observe that Langat Dam as dam often that intercept sediment transport by the river. The dynamics of sedimentation within the reservoir can impact the dam efficiency, water quality and long-term stability. Dams may have sedimentation management strategies in place. Besides, the effect of fluid dynamic based on dam is the turbulence, as it can occur in the reservoir due to wind, inflow or outflow dynamics and temperature variation. Next is, based on our research, we found there is an annual report from Nahrim as they install the water pressure mechanical pump near to the site of the Sungai Congkak, as it's an innovation product to pump water using a piped water pressure that can pump 10 liters in just 30 minutes duration. An effect from this water pump, the water pump pressure may increase the flow of water, creating a stronger currents. These stronger currents can pick up and move more sediment along the riverbed. The increased water flow generated by the pump enhance the ability of the water to lift and transport sediment particles, potentially causing changes in the riverbed composition. Next is the hydrodynamic modeling. In this section, we used over numerical models the simulation to predict the movement of the sediment in natural water systems such as rivers, lakes and coastal area. In this equation that we found is the Reynolds numbers, continuity equation and the Meyer-Peter-Muller equation. Reynolds numbers is to predict the transition from laminar to turbulent within the fluid system. Below is to show the equation of the Reynolds number. Next, for the continuity equation, it stipulates that the mass of fluid entering a controlled volume must equal the mass existing the controlled volume, provided no accumulation or depletion occurs within. Based on this, we can sense that A1 V1 equals to A2 V2 is also the same on the flow rate equation. Last but not least is the Meyer-Peter and Muller equation. It is a seminal empirical formulation utilized for quantifying the sediment transport rate in open channel flow such as river.
Hi, Assalamualaikum. My name is Ahmad Faris. Today I want to present about sediment management in river system. A comprehensive strategy to ensure both elemental preservation and infrastructure longevity. Firstly, dragging a mechanical sediment removal technique proved invaluable in addressing localized accumulation, safeguarding navigation channel, concurrently adjusting dam operation, dynamically regulate downstream sediment transport by modifying water release schedule. Next, the construction of sediment trap emerged as a strategic approach, capturing particles before critical point and facilitating control removal for optimal flow condition. Complementing this active measure, vegetative stabilization through enhanced riverbank vegetation to minimize erosion and reduce sediment input for long-term river ecosystem health. Strategically modifying channel. Strategically modifying channel geometry influence sediment transport pattern. By a selective withdrawal system with dam allow precise control over sediment release depth, contributing to adaptive management practice. Next is a riparian buffer zone, characterized by native vegetation along riverbank, act as crucial passive strategy, naturally filtering sediment, maintaining water quality, and preserving the ecological balance of river environment. To ensure effectiveness, the implementation of comprehensive monitoring and adaptive management system is paramount. Real-time assessment and adjustment based on evolving conditions contribute to sustainable and efficient sediment management. Tailoring these approaches to each river system specific characteristics promote a holistic and sustainable framework, minimizing environmental impact while safeguarding hydraulic structure for long time. Next is impact assessment. Our evaluation span various dimensions, focusing on the effectiveness of implemented strategies and their environmental repercussions. Our crucial aspect involves scrutinizing how proposed sediment management strategy influence overall sediment transport pattern within the river. We aim to determine whether adjustments are necessary to achieve optimal outcome in mitigating sediment-related challenges. Furthermore, the environmental impact assessment is integral to ensuring our strategy aligns with sustainable river management principles. We delve into potential ecological consequences, considering factors such as alteration to aquatic habitat, impact of biodiversity, and downstream effect. This comprehensive evaluation seeks to strike a balance between sediment control and ecological preservation. Moving forward, our assessment explores the long-term implication of chosen strategy, examining their sustainability over a extended period. We consider whether unintended consequences arise or if adjustments are needed to maintain equilibrium in the river ecosystem. This forward-looking perspective is vital to ensure that sediment management practice contribute to the resilience and health of the river system over time. In conclusion, the impact assessment serves as a critical checkpoint. We strive to ensure the sediment management strategy not only effectively address immediate challenges but also align with environmental sustainability goals. By comprehensively evaluating both short-term effectiveness and long-term ecological consequences, our study aims to guide the implementation of sediment management practices that are both efficient and environmentally responsible. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nursaidatul Asyhikin with Muhammad Izani, and I will present about the sediment dynamic. Sediment size. Sediment size is the range of particle size that comprise sediment or the substance that sink to the bottom of the liquid. Particles of different kinds include rock, minerals, organic debris, and other components can make up sediment. As you can see, this is the sediment size, which is we can see clay is particle with diameter less than 0.002 mm. For silt, the diameter is between 0.002 mm until 0.063 mm. For the sand, the diameter between 0.063 mm until 2 mm. For the gravel, particle is diameter between 2 mm until 64 mm. For the cobble, diameter between 64 mm until 256 mm. And for the boulder, the diameter is greater than 256 mm. This is the Sungai Congkak, and based on the figure show, the box E is the place where cobble and boulder sediment are found. Meanwhile, for box F is the place where silk sediment is located, which commonly exists along the riverside. Lastly, box G is the place where other sediment types are found, for example sand and gravel. Next is the sediment shape. Sediment shape is the physical form or arrangement of the individual particles that comprise sediment. Sediment particles can have a wide range of shapes, and these shapes affect the way the particles interact with the surrounding and with one another. This is the sediment shape. There are 5 types of sediment shapes, such as angular, subangular, rounded, subrounded, and well-rounded, also very angular. So, based on the observation made at Sungai Congkak, there are various types of sediment. Most of the river rock have a lot of rounded, subrounded, and well-rounded sediment, including the observation place, which is Sungai Congkak. Next is sediment density. Sediment shape is the mass of sediment per unit volume, the kind of particle present, the level of compaction, and the quantity of pore space between particles are few examples of the variables that might affect sediment density. The density can be influenced by several factors such as particle type, pore space, degree of compaction, moisture content, and cementation. This is the effect on sediment transport and deposition. For the sediment size of sediment particle affect their susceptibility to transport. Generally, smaller particles, clay and silt, are more easily transported by flow of water, while large particles, which is sand and gravel, require high energy condition for transport. While in context of deposition, large particles tend to settle out of suspension more quickly than smaller particles, contributing to the formation of coarser deposits. For the context of sediment shape, angular and rough sediment particles offer more resistance to fluid flow, requiring higher energy conditions for transport. Rounded particles are more easily transported due to reduced friction and interlocking. While for deposition, angular particles tend to interlock, forming stable deposition that resist erosion. Rounded particles, on the other hand, may settle more closely together, leading to well-sorted and well-stratified deposits. For sediment density, for transportation, sediment density influences buoyancy and settling rate, which is higher density particles settle faster in water, while lower density particles may remain in suspension longer. For compacted sediment with reduced pore space can also be more resistant to erosion. For deposition, higher density sediment often contribute to more stable deposit. Compaction, which increased sediment density, can lead to the formation of sedimentary rock over time. Lower density sediment may be more prone to erosion and remobilization. Next is the design of hydraulic structure. A hydraulic structure is a structure submerged or partially submerged in any body of water which disrupt the natural flow of water. They can be used to divert, disrupt, or completely stop the flow. This is the water diversion, which is constructing the water diversion can help to increase the flow rate of river flow. Flow is required to initiate the transport. Introducing water from other sources such as tributaries or alternative water supply can increase the overall flow rate in a river. Next, the sediment trap. Designing a sediment trap, which is a temporary containment area that allows sediment in collect stormwater to settle out during infiltration or before the runoff is discharged through a stabilized spillway or dewatering pipe.
Environmental consideration. Sediment transport leave a significant environmental consideration that play a significant role in shaping ecosystem, water quality, and overall environmental health. Sustainable rivers manage planning, building, and conserving river ecosystem with care to satisfy the requirements of present and future generations. During our mini project, we noticed that the riverbank is eroded by the water. On the article that we found, there is a headwater phenomenon. In 2021, a group of students decided to go to Sungai Congkak, but unfortunately, they come at wrong time because when they bath in river, a sudden headwater phenomenon occurs and one of them is drowned. It is advisable to avoid water activities during monsoon and observe the water first. This is why during our mini project, we noticed that the riverbank is eroded by water. The good news is there is a mission to clean up the Sungai Congkak. On the 17 June 2023, Brand sent a cleanup crew on a mission for World Environment Day to Sungai Congkak. The main activity is to collect trash along the river and road indirectly reduce amount of solid sediment.